Okay, so today, are you ready? Big day. Common Core Standards is radians and the unit circle. Okay, now the application for radians is amazing, but we're not going to understand the applications yet. It's going to take about a week before we truly understand why we even do radians, okay? Today's date, 5/2/18. Okay, so first of all, let's just take a look at the definition of a radian. First of all, before you know anything, a radian is an angle. It's an angle, okay? A radian is an angle measure that relates the arc length to the central angle, okay? So this theta here, this angle is exactly 1 radian because the radius is 1 and the arc length is 1, so that if you have a unit circle, the angle must equal the arc length. So in this case, this is 1 radian. Theta is equal to 1 radian. It's about 57 degrees. And we're going to find out exactly what it is in these notes, okay? So if you're to measure 1 radian, it's about 57 degrees. But degrees are for dummies. We're going to stop using degrees. We're going to start using radians, okay? So we do know, there it is, about 57 degrees. We do know that if you go all the way around a circle, its circumference is 2 pi, okay? So if we're trying to relate the angle to the circumference, then all the way in the circle is 360 degrees, but now all the way around the circle is 2 pi radians. So as far as 360 degrees, that's going to be 2 pi radians. It's an angle. A rotation all the way around the circle is a rotation of 2 pi radians, okay? So then we also know then if we went halfway, it's going to be pi. So halfway, 180 degrees, is pi radians, all right? Once we know that, okay, we know then that two things, that if we had a radius of 1, then the length, the arc length from here to here is exactly pi, or 3.1. If we take a measurement, drape it across the circle, take it and measure it, the length of this arc here is going to be 3.14 blah, 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 or pi, okay? So now we have is an angle that is related to its arc length, okay? So if that's the case, if this is pi radians, then 90 degrees is pi halves, okay? And we have that on our circle that we drew, right? 90 degrees, pi halves, there it is. We know 60 degrees, which is a third of 180, and again, we have that on our circle, so we take a third of that. That's going to be pi thirds, right? We looked on our circle, 45 degrees, we know that is pi fourths. And if we were to use a calculator just for the heck of it, I want to show you this works. Pi divided by 2, 1.57. So the arc length from 1 here to here, the length of it, 90 degrees, is 1.57. That's the length of the arc, which is also an angle. It's also an angle, okay? 30 degrees, we know, is a sixth of 180 degrees, so this is pi 6. And again, we have in our circle, right? 120 degrees, okay, 120 degrees is from our circle. We can go 120, we know, is 2 pi thirds. Okay, that's the angle or the radian equivalent, okay? 150 degrees, we know we just drew our circle, is 5 pi 6. Okay, we just got it from our circle. It's easier to take it from the circle than this chart, right? 135 degrees, we know from our circle is 3 pi fourths. That's a 5 by 11, 5, 3 pi fourths. Okay, it's an angle, okay? 210 degrees, we know from a circle is a rotation of 210 degrees, which is 7 pi 6. 225 degrees, which is going all the way around past 180, we know from our circle it's 5 pi fourths, 5 pi fourths. 240 degrees, again, which is on our circle, is a rotation beyond 180 degrees. As in radian, it is 4 pi thirds. 270 degrees, rotation on our circle all the way around the circle. 3/4 of the way is 270 degrees, or 3 pi halves. So that's the radian angle. It's also the length of the arc. They are the same. 300 degrees. Go all the way around. Rotate beyond 270 is 5 pi thirds for the radian equivalent. 315 degrees, almost all the way around the circle, is 7 pi fourths. And then we already did 360 is 2 pi, okay? So these are radians. These are angles. These are angles, and they're also going to be equal to the arc length, okay? That's what makes them so important, okay? Now, David, you asked a great question. What if it's not on the circle? And we could do 15, and we could do all these other angles, but that's just crazy, right? So a formula would be helpful. So we have a formula. If we want to convert degrees to radians, we have a formula. We take our degree, divide by 180, and we multiply it by pi, okay? So as an example, let's look at example 1. If we have 20 degrees, again, we wouldn't want to put 20 on our unit circles. Too many angles. It gets too crowded, right? So, okay, we're going to take our 20, it's a degree, put it in for the D. Okay, so we'll go 20 over 180 times pi. Okay, now I can reduce this fraction. May as well reduce it, make it look nice. So reduce it, right? Reduce them both by 20, reduced by 20, it's going to be 1/9 pi, or, and that answer is great, or pi over 9 is normally what you see, okay? This is the radian equivalent of 20 degrees. And we just used our formula to get it, okay? Pretty easy, right? Negative 260. Now, because you're on a circle, you can have negative angles. And normally you can't have negative angles. But what does a negative angle do? It just is a rotation backwards. Well, real quickly, let me just draw a picture, and we'll get the radian equivalent. But if you did a circle, okay, you got 0 degrees here. Instead of rotating forward to have a negative angle, you just rotate backwards. So negative 260 degrees is probably right about there. Does that make sense? Rotate, because that's 270. So a negative angle is just a backwards rotation. It's kind of like backing your car up and your wheel spins backwards, right? So we're going to use our formula. We're going to go, okay, negative 260 divided by 180. So I'm going to take my 260, put it in for the D, for degrees, right? Tack on pi, okay? Let's see if I reduce this. The zeros reduce 26, 13/9. So, okay, how about negative 13 pi ninths after I reduce it? Okay, I just reduced it. Reduced it by 10 first, then reduced it by 2, right? Reducing fractions. And if you don't know how to reduce fractions, I'm sorry, go back to the 6th grade. Okay. Now, you can do the same thing with radians. So we put in our force, right? We got our pi force, we got our pi thirds, pi sixths. We could put in pi eighths, but again, the circle is going to get too crowded. You agree? So instead of putting every single angle you think of, there's a formula. So how do you do it? So to make it into a degree, you take your radian, which is my 3 pi eighths, and multiply it by 180 over pi. So let's do that. So to convert this to a degree, we're going to go 3 pi eighths. So put our 3 pi eighths right here for our radian, for our r, right? I'm going to multiply that times 180 over pi, okay? So I'm taking this value, put it in for the r, times 180 over pi, and then I'm just going to, may as well cancel the pi's, okay? That cancel pi's, right? And then I'm going to go, what's 3 times 180 on 3 times 180 is 540 divided by 8, right? 540 divided by 8. And I get about 67.5 degrees. Okay, there it is. So that's the degree equivalent of a 3 pi eighths radians. They're both angles. They're both the same angle. One is described in radians. The other is described in degrees. Okay, so now, negative 7 pi 12s. Again, you can do this because negative angles are okay because it's just a matter of rotation. So again, try to take a look at a circle. Where is it? Right? If this is 0 degrees here, right? So rotating forward for positive degrees, we're just going to go backwards. So negative 7/12 is awfully close to 1/2. It'd probably be close to right about here somewhere, that much rotation. So it is an angle. but it's in terms of radians, okay? So negative angle is just a backwards rotation. So let's use our formula. Let's put them in. So I'm going to take and plug my negative 7 pi 12ths right in for r, okay? Put it in for r. So I'll go, all right, negative 7 pi 12ths, right? Put it into my formula times my 180 over pi, right? Okay, so just plug my radian in for the formula for r and multiply times 180 over pi. Again, the pi should cancel. Cancel, cancel. And I go negative 7 times 180 divided by, negative 7 times 180 divided by 12, right? And I get an answer about negative 105 degrees. Okay? So I know that my angle then is about negative 120 degrees, right? 105 is right. I'm dyslexic. I can't see. Thank you, Claire. 105 degrees. There it is. Okay. It's really easy. You guys can see it. Okay, so that's all I have. We got plenty of time to get this done.